The Galileo probe, which sent its spacecraft into the atmosphere of Jupiter, was the most demanding entry probe ever flown by anyone, and it worked perfectly.
Europa and some of the other satellites where there seems to be accumulating evidence for water are getting to be very, very interesting places for exploring. I mean, who knows what's under the ice surface in Europa? You've got water. It looks like there's salt water. You wouldn't have water if you didn't have a source of energy. The odd coloration gives some hint of the presence of organics. When those conditions held on the early Earth, life developed in a couple of 100 million years. Well, maybe there's something interesting on Europa.
I tell you, there is nothing as beautiful as Chandra sailing off on its way to work.
Nowadays, we're discovering what is the universe really like, and it's totally magnificent. And one can only be inspired and awestruck by what we find. So I think a proper response is complete amazement and awe at the universe that we're in. And how it works is just far more complicated than humans will ever properly understand.
Houston, Atlantis, we have capture.
Mir was a successor to the early Salyut space stations that the Russians built back in the 70s.
Well, I was extremely fortunate that I was able to be part of the Shuttle Mir program. So obviously, there were a lot of challenges when you're trying to work with a different culture. I mean, it was a challenge for the Russians, it was a challenge for the Americans, but everybody wanted to work together to make it come to pass.
I definitely think it started teaching us the lessons we needed to learn, and it was key to that. Very technical things that, you know, seem simple but become very complicated just by language and cultural definitions of things that, you know, I think our guys did a phenomenal job bringing all those pieces together.
Booster ignition and liftoff of Discovery with a crew of 6 astronaut heroes, 1 American legend.
The flight I was on, Discovery in '98, we had 83 different research projects on that one flight. You go up for a couple of weeks, say, and you find some of the things occurring on the human body that are much the same as getting old right here on Earth. The body's immune system changes. You get less resistant to disease and infection. The body's ability to replace protein in the muscle becomes less. And so the question was, could we find, by comparing my reaction to the younger people's reaction to this up there, could we maybe get a clue as to what within the body turns the human system on and off with regard to immunity? Hopefully we can find ways maybe to make it possible for younger astronauts to go on longer missions without having some of the problems they have, and at the same time cut out some of the frailties of old age for people here on Earth.
Houston Endeavour, we've got Unity firmly attached to Endeavour, and we're off to a great start on building the International Space Station. Houston Endeavour, we have capture of Zarya. Physical separation, executing SEP burn.
We have ignition and liftoff. Liftoff of the Soyuz rocket. We have initial contact of the Soyuz capsule with the Expedition-1 crew to the International Space Station.
The hatch was opened at 102140 Universal Time. The first expedition on Space Station requests permission to take the radio call sign Alpha.
We are on a true spaceship now, making our way above any earthly boundary, that our crews can work together as equals and our countries as partners.
All the other vehicles we had ever built could be totally assembled, put together, and tested on the ground. before you launched them into space. The space station is so large, you know, it's 360 feet wide, 280 feet long, 120 feet thick or something like that. It weighs 1 million pounds, and it takes 46 or 47 assembly flights just to take up all the pieces. So every time you brought up a new piece, you had a different spacecraft that had a different set of requirements, and basically a new spacecraft. And at each stage, it has to operate completely successfully for an extended period of time.
Even as the International Space Station was being assembled in orbit, Spirit and Opportunity would soon rove the Martian landscape. But early in this new millennium, we would endure a tragic reminder of the dangers of space travel.
And Columbia, Houston, we see your tire pressure messages, and we did not copy your last.
Roger.
At 9 o'clock this morning, Mission Control in Houston lost contact with our space shuttle Columbia. A short time later, debris was seen falling from the skies above Texas. The Columbia is lost. There are no survivors.
NASA has been charged with advancing the technology and understanding of spaceflight for this country, which means we're on the cutting edge of what can be done. Then we're going to be taking risks.
And spaceflight is one of the areas where we face risk on a daily basis. And in the process of doing this, we develop the new technologies, new techniques, the new inventions. We make discovery. This is what's going to keep us powerful and safe and secure and assure the economic vitality of our nation.
One, two, three.
We actually put our many years of hypersonic research here at Langley into work, into a vehicle that actually flew with the HyperX program, which was indeed an exciting program. This was put on a Pegasus booster, taken up to test point, and then released.
3, 2, 1, launch.
Sequence reset. At that point, the X-43 would ignite. We had two vehicles, Mach 7, and then we had a Mach 10 vehicle. We broke our own record. Mach 7 was the first record breaker, and then we broke our own record with the Mach 10 as far as speed.
I had a great time working on airplanes and fighters and stuff. The agency not only built and flew some very cool things, we also had a lot of research that then got onto other airplanes. We did a lot of work that ultimately led to things that are on the F-22 and F-117 and maybe on the Joint Strike Fighter. We don't build 747s and we don't build F-22s, but we certainly did things that help the companies that do build those kind of flight vehicles make their airplanes better.
It was a good maneuver.
3, 2, main engine start, 0, and liftoff of the Delta rocket with Opportunity, a chance to explore and unlock the secrets of our neighboring planet.
The reason we send unmanned spacecraft is to pave the way for humans. The reason we've got Spirit and Opportunity on Mars is to tell us a little bit about what it's going to be like, the things we're going to encounter when we get there. Because it's man's intellect, it's man's intelligence that you can never recreate this computer.
We intentionally made them so human. We gave them 20/20 vision. We gave them the ability to move around in an environment. We gave them an arm so that they could reach out and touch things. And then we used them to do exactly what we would do if we were there.
One thing that NASA gives us is a very different perspective on the whole universe, including our own world's place in it. When we look at other worlds and we look through the eyes of a